Welcome to my game development laboratory, and to the first simpler game dev video as well. So I started rebuilding my extension from scratch. I also renamed it to Gear. It will be better structured and will have more features, of course. It will contain multiplayer feature, better save and load systems, better collision system, proper raycasting, better animation system and many more. I also tried implementing neural networks for a while, but to no success. For this first video of the series, we will be making the first video game ever, Pong. I've made the network part as simple as possible, and of course everything seen will probably soon change. For the better, I hope. Let's dive into coding. I have already imported a default font, a ball sprite and a paddle sprite. The first thing we need to do is to inherit the extension instance. This will force us to overwrite two methods. Mouse hovering the error and pressing Alt and Enter will create those for us. The first method should return this class, and the second one contains all the game code. Let's get the multiplayer stuff out of the way first. We have to check now whether this is the very first time the game is calling this function. This way, the code inside this if statement will execute exactly once at the very start of the game. We will hide the window and bring up the console from which we need to receive an input from the user for whether he wants to start a server or connect to one. Once this is done, we clear the console and process the input. Typing server surprisingly starts a server, and typing client will present another input for the IP. Once the IP is typed, the user connects, his game window shows up and we display some score on it. To test everything out, we need a local network. That might be the same device connecting to itself, or two devices on the same router connecting to one another. The server displays all of the IPs for that. But what about long distance connections outside of our Wi-Fi? This is a somewhat complicated topic, but long story short, all routers block most of the incoming connections. If the router doesn't block it, then probably the Windows firewall will. Going around those is very tricky. Perhaps the simplest way is a virtual private network program, also known as VPN, something like Hamachi or Radmin. The server also displays that. I prefer Radmin since it doesn't require any registrations, and the network capacity is up to 150 computers. So connecting through it and its IP and testing that out turns out fine. We can create a server and connect to it. Let's go ahead and create some variables for the things we need to keep track of throughout the game. Those being some ball properties and the score itself. Then we shall create both paddles and the ball to their according positions, with the right sprites and sizes. We also instantiate the ball's direction here. It will always go left at the start, because the first player to connect will take the left paddle, and he will be ready to meet the ball once the second player connects. Another thing we have to pay attention to is that we set some way of identifying the paddles. Each client connecting to the server has a unique name. In this case, we chose their unique name, which is client, for both players, which isn't very unique. So the server corrects that and notifies the clients. Therefore, the first client gets the unique name and the left paddle. The second one receives a free unique name and gets the right paddle. That's just to avoid nicknames and further complication. We are done with the start of the game. Starting the game now should show us the sprites. And now to the updating of the game. It is separated in two, client side and server side. As a client, we want to take the user's input, and according to it, and some other gameplay information, like whether the paddle is leaving the screen or not, we update the paddle's position for this client. The key difference between both clients is their unique name. By that, we pick the correct paddle. Let's test that out. And yep, we can move that paddle up and down, but cannot go outside the screen. Everything is working, but only for our game. Both the server and the other client cannot see our paddle moving. So let's notify them about our paddle's position. Since we don't need such a fluid gameplay, we can send a message over the network every third tick. This means that our paddle on everyone else's screens will be updated around 20 times per second if we run our game at 60 FPS. This will reduce the amount of work about 3 times for all computers involved and will be barely noticeable for the users. Sending a message to all clients and the server is the same approach I use in my wizard game that I am making with Construct. With it, a hacker might send some invalid position that might break the game or even the server, which is never good. But for the sake of simplicity, we will keep it this way. A proper way of doing that would be sending the data only to the server validating it and updating everyone accordingly. After sending the message, we have to receive it on the other end. I've implemented a way to receive all incoming network messages by overriding this method. Here we can check where the message originates from, and since the server has no unique name, we can separate this method to server and client side again, like so. A client can only inform us about his paddle, so we can directly interpret the message and update his paddle on our screen. Let's test that out. And it's all working. To the server side we go next. Here we have to update the bow movement. Updating the bow comes with all sorts of collisions, so we need a lot of data for them. I haven't yet implemented a proper collision system into my extension, so we use distance and treat everything like a bow to keep it simple. The first kind of collision is one with the paddles. This reverses the bow's horizontal movement, randomly adjusts the movement direction and adds some speed to the bow. The second kind of collision is with the horizontal bounce of the screen. There, we reverse the bow movement vertically. The third one is with the horizontal bounce of the screen, which increases some score points to the according player, updating the clients in the process and resets the round. Then again, every third tick we have to update all clients with the new bow position. On the other end, we catch those messages as a client. This time they originate from the server and we have to check the meaning of each message since the server updates us about the score and the bow position. We shouldn't confuse those or that would be game breaking. Our game's bow and score are updated accordingly and so is the text for the score. That's about everything our game needs in about 200 lines of code, including the comments and the local variables that improve the code readability. We can of course separate things into classes and functions, but that's as simple as it gets. Hopefully you're starting to see what I'm aiming for with my extension and the simpler game dev series. So if you're finding this as interesting as I do, make sure you stick around.